Majority of the world's population have seen a robot in their lifetime. And if there is a robot, there is a company behind it. And if there is a company, then the company would be needing skilled developers to build the product. In general sense, that happens everywhere. So in this video, we are going to be discussing many key aspects that software developers for robotics should keep in mind before applying to a job. Here is a checklist that one should check before going for the action: mindset, skills and intelligence, specialist versus generalist, and career paths. Now all this is going to be really interesting for you because the very first thing to set is mindset. You have to think in a way that makes you more attractive for the companies. The first point is about the companies. Do they want people or not? The answer is companies want skilled people as much as they want to sell their product. So you can feel that when selling a product, the company is pushing a lot, so as the company pushes their HR teams, the interviews, everything when they are hiring a person, because most of the things of the product development are dependent upon the developer they are hiring. So companies need people as much as they want to sell a product. Skills versus intelligence is a simple comparison. You can understand it in a way that if you are skilled enough to something like writing a C code, for example, and you're not intelligent enough to have a 200 IQ, but you know how to write a C code, then company will prefer you in case of development specifically. Because if you can't do the thing and you have very high intelligence IQ, it doesn't matter. So do the hard work and you can attract a company. The third point is really important because when you are getting into a job mindset is to have a specialization in one thing. You're not generalizing. You cannot be working on drones and mobile robots for a commercial quality product by jumping 6 months to this, 6 months to this if you are starting out, because this video is all about starters and intermediate. The thing is, you need to understand in a way, if I want a cook and the cook is required to make something out of chicken, I will never hire someone who is good at cooking vegetables. General example. So you can understand, if a company is making a drone, you should not be skilled enough in mobile robots, although there are certain things that are common, but still, if you want the company to be attracted towards you, you should be working on drones. So this is what you should be specializing in. What I mean by specializing, we'll discuss in the career path. But for example, in robotic arms, there is no localization problem because the robot is always still. Not talking about the mobile robotic arms, but static robotic arms. But in drones and mobile robots, there is a lot of localization problem, and that is a proper career path in itself. So be a specialist in a specific robotic type of which the company is producing a product. These are the examples of some companies for robotic arms, drones and mobile robots. Obviously there are exceptions. Some companies are making both of these things, mobile robots and robotic arms. That's upon you. Career paths. This is the most important part of this video because most of the people ask me that I'm good with this thing, this thing, this thing. Is robotics good for me? So you have to understand the holistic picture of robotics. If I talk about drones and mobile robots, which are moving, not robotic arms, you should start as a software developer. Number one, getting sensor data. You should be understanding how the data can be utilized with good programming practices. The second thing comes with the sensor fusion, utilizing the data, multiple sensors data, and combining it to produce one outcome. The next thing is localization. When you perform sensor fusion, then you come to the localization part. Now this is the very basic step. When you make the robot move or fly, you should know where it is. That's a robotic problem. Where am I? Or there are other approaches as well. So this is the first thing, localization when the robot moves. When you have the good localization algorithm or a software, then you move towards the next step, that is mapping. You build a map around your environment, you understand what is around you, and then the next thing is path planning. You have the map, you make a path. If you want to go from this room to this room, you have the map. From map you understand what are the available options, occupancy grades and stuff. Then comes the navigation part. In navigation you perform motion planning as well, that I have the path in the map and we know the robot's location through localization. Is it possible for the robot to follow the path? That's motion planning. Last thing that I would say, last thing for now, is navigation, which brings in whole control systems, how the robot is going to deal with the errors while making the move, the external disturbances, the electronic connection controlling. The control system is again something really big than all other. These are the main career paths that you can take in software development of robotics, and there are other as well, but these are the base that you should understand or have a know-how about what is happening in these. Now the main question people ask most of the time is, where is AI in robotics, or robotics is AI, or AI is robotics, something like that. You have to understand in this way. I have given you a brief introduction to the robotics, but let's say I have to make the robot move towards left or right. Should I use AI for that? It's just an example. If you have a condition in which you set one pin to be one, that takes very small milliseconds or microseconds, that makes the robot take a turn left. But if I say everything is AI, so I train a model and then I implement that model. To utilize that model, I import some libraries, that is a memory overhead, and then I test that model and it's somehow 60% efficient, 70, 80, 90%. Then I spend time on improving that model, F1 scores, sellout scores, the matrices and all that stuff, improving that model. And then comes the point of implementing the actual model. But why should I waste so much time on that AI implementation? Why should not I just use 0, 1 to just make a left turn? So this is the basic common sense, that you need to first go through the available algorithms for a specific task. And if the parameters of the algorithm is increasing enormously to control the behavior of the robot, then comes the shift towards AI. That's what I have experienced in 3 to 4 years. In most of the scenario, people think that just give the raw data and everything is going to be controlled by the AI. But when you are making an actual robot, lower computational power, lower resources to compute. We don't have multi cores, and the GPU even on the robot microcontroller. So we have to utilize those resources and perform in a very basic manner. So that's all for this video. I hope you understand. If you have any question, you can directly ask me. I'm also looking for valid questions that I can answer and that will help people.